Hello and welcome to this Python project made by Daniele Martinelli, M.Ussano and Alessio Russo, students of Automation Engineering from the University of Naples, Federico II. It's my pleasure to introduce you to Iris, the chatbot of the future. As a self-learning generative chatbot, Iris is able to have a conversation with the user to chat with him. What is more, Iris can increase its knowledge thanks to the Internet database. The user inserts the website and Iris pull out the document from there, adding it to the corpus. Finally, works on the document, grabs the meaning of the text, and use it to give to the user some coherent answers.
The first module that we use is CORPUS.PY. The aim of it is the creation of resources for our bot. In the first line, as we can see, there is the import of our modules that we are going to use. Beautiful Soup to pull out data from an HTML file, and urlib request to obtain an HTML file from a URL, so just from a string. Glob and OS, finally, they are used just to manipulate files, so to create files, to create folders, to create files, to delete files, and stuff. Finally, we have these constants that are created just to make more customizable the file, the whole code, to change, for example, the way that the folder is called, how they are going to be saved, and stuff like this. The first function that we see is checkRepo. Its only aim is to create the repository folder if it doesn't exist. So if it doesn't exist, create this folder. If not, don't do anything. The second function is newFile. newFile has to check if there are some new files or some changes into the resources of our chatbot, Iris. Indeed, if we use the library txt that we defined here, library txt, as our index for our resources, so if there has been some changes, like some file has been removed from our resources for some reason, because, for example, it has been corrupted, it returns true. If something instead has been added, because, for example, we want to add some new information to our knowledge base, it returns true. So instead, it returns false if there has been any kind of change into resources. The third function instead is create. Its arguments is the path of our resources, and it returns an output that is the path of the corpus of Iris. The only thing that he has to do is to update the titles in our library for the next iteration, and to create the whole corpus for Iris. Finally, we have the add element. The add element is the main function has to obtain data from an HTML file. So the first thing that has to do is to obtain the URL, converting it into the HTML file, and from it pull out the text using as a parser HTML5lib. Now, we have decided to use HTML5lib rather than LXML because even if it's kind of slower, but it's more efficient. It can find better and scrape better the text files. After we obtain the HTML file and the text from it, we have to make it easier to Iris to understand. So we have to break it into lines and removing leading and trailing space on each, break multi-headlines into a line each, and drop blank lines at the end. After this, we have only to create and write what we had, so the text itself, into a file that is going to be called resource plus a number that is going to be incremented each time we add a file into our resource.
In this module, Chatbot.py, we're going to analyze iris reasoning. Here, I'm going to briefly introduce the libraries we will use. The I/O contains all the function for the I/O stream. We will open only text file in read-only, write-only, and read and write mode. As the name says, random implements a random generation of number. In text, it chooses an element from a sequence, for example, a list. String is the library needed to work with strings. I remind you that the text, before to be preprocessed, is a string, is a huge string. Warning messages alert the user to an expected condition in the program. M.Py provides us all the utilities to work with matrix and arrays. Skilllearn feature provides the utility to extract numerical feature from the content. In other words, we use it to tokenize and normalize the text. I remind you that tokenize means that we divide the text into tokens, and normalize means that we remove from the text all the rumors like uppercase, punctuation, stuff like this. Skilllearn matrix pairwise evaluates the distance between vectors in terms of similarity and affinity. Indeed, we use from this library the function cousin-similarity. Finally, NLTK, that stands for Natural Language Toolkit, contains the function to process the text, the human language. In Chatbot, we have one huge function that contains other utilities, iris. First of all, it creates the corpus, opening the file corpus in reading mode. Then it reads from that file and takes the text in lowercase. We tokenize the string of text. Using send-tokenize, we create a list of sentences. With word-tokenize, we create a list of words. Here, we does lemmatization, which means taking a word and looking into the dictionary for a corresponding lemma. Lemmatizing is similar to stemming, apart from the fact that with stemming, you take the risk that the root of the word does not exist. Moreover, we normalize the tokenized text. With the function lower, we transform the text in lowercase, and with the function remove punctuation, we remove the punctuation symbols. This section is about iris chatting abilities. We define 3 lists with some greetings that iris can receive from the user or give to the user. We also have the function greeting that takes a sentence as argument and checks with the iterative for loop if all the words in these splitted sentences are present also in the list being input. If so, it returns a randomly generated element from that list. This is the main function of this module, where iris actually generates the answer to give to the user. First of all, we create an empty string iris. After that, we add the user response to the send tokens list, which is the iris, the chatbot knowledge. Then we create a vector of lemmas with the function tfid vectorizer. This vector became later a matrix with the function fit transform from the same library. Now, with the function cousin-similarity, we calculate a coefficient of similarities between the last element of the list send tokens, which is the user response, and all the other sentences that are the knowledge base of the chatbot. Cousin-similarity is a function that calculates the coefficient of similarities as the product of the 2 vectors divided for the product of the 2 vectors normalized, as we can see from the formula. Namely, it projects the two vectors into a sphere and defines the product of the two as the cosine of the angle between them. What happens now is very simple. We sort the vector in an ascending order following the coefficient of similarity. Then we create a one-dimensional array with all the sentences. We sort this array and we save the sentence that has the highest value of coefficient similarity. I remind you that this element has to be the user request, the response, because it actually is the same sentence. Finally, with the conditional if clause, we check if the coefficient is 0, we assign to the string iris, sorry, I don't understand you. If it's not, we assign the send tokens with the highest coefficient. Here is the last part of the function iris. We use a flag to manipulate the interaction between the chatbot and the user. While the flag is true, we check if the user input in lowercase is present in the list ending input. If it is thanks or thank you, the chatbot shows his gratitude to the user and move the flag to false. If the user is saying hello to the chatbot, Iris greet the user. Otherwise, the chatbot answer to the user input. Last case, chatbot and user are saying goodbye to each other.
The last module of this is Main.py. So in Main.py we import corpus and chatbot, and so we define the user interface. In user interface, the user can choose 1, 2 or 3. We enter in if, so if user press 1, we can add a null, and so we use the module corpus.add. If user press 2, we can chat with Iris. If user press 3, we return false, and so we break the while loop. Else there is the if the user don't press 1, 2 or 3, we have the invalid error. This is our main, the interface of Iris. We can run it. The first answer of Iris is what you want to do, so we can insert something. So we can insert a new rule. So we can take the Wikipedia page of Neapolitan cuisine and we can paste it. When we paste this rule, we create a new resource. In this resource there is the page of Wikipedia of Neapolitan cuisine. So the knowledge base of Iris is have a new resources. We can chat with Iris. We can ask a question. So a question about the Neapolitan cuisine. She say that spaghetti dressed with tomato sauce, black olives, frongaeta and capers are called spaghetti alla puttanesca. We can say bye. And now we can insert another rule. In this case we can insert also more rules. We can take other rule, that is Ziegler and Nichols. We can insert another rule, and so we can take coronavirus disease and Turing test. How we can see, the resource, there are new resources, 3 new resources about Ziegler-Nichols, the coronavirus, and the Turing test. We can chat and we can ask about these 3 arguments, the Ziegler and Nichols. So we say the Ziegler-Nichols tuning method is a heuristic method on tuning field control. We can ask about the COVID. The virus is primarily spread between people during close contact, and so on. The last question about the Turing test. So, did Turing So, we have our answer. So, Turing did not explicitly state that the Turing test could be used as a measure of intelligence or any human quality. We can quit it. We can say bye. Now we use only the Wikipedia page. We can also use another page. We can also take another rule or another page. It is data structure and algorithmetry on tutorials point. Can insert the rule. And so there is a new resource about this argument. The last question, so we can chat. So we can ask what is a pattern of the algorithm. He responds path refers to the sequence of nodes along the edge of tree. We can say also goodbye and we can quit. So tree. And so this is Iris, the future of chatbot. Thanks for attention.